Hey everyone! Welcome back to Bug No Jutsu, where we simplify coding problems with easy explanations. Today, we'll solve an interesting SQL plus Pandas problem from LeetCode, 1661. Average time of process per machine. We'll first deeply understand the problem, break down the example step by step, then I'll explain the SQL approach and the Pandas approach, describing why we use specific methods, and how to think like a problem solver. So make sure to watch till the end for some key insights. Let's dive right in. Alright, here's the problem. We're given a table called activity, where each row represents an activity done by a machine. The table has machine_ID, the ID of the machine, process_ID, the ID of the process running on that machine, activity_type, either start or end, indicating when a process starts or ends, timestamp, the time when that activity happened, as a float value. Our task? For each machine, we need to calculate the average time taken per process. To do this, we find how long each process took, simply subtract the start time from the end time. Calculate the average of these durations for each machine. Finally, round the result to 3 decimal places. Let's look at the example given. Machine 0 ran 2 processes. Process 0 started at 0.712 and ended at 1.520. Time taken: 1.520 minus 0.712 is equal to 0.808 seconds. Process 1 started at 3.140 and ended at 4.120. Time taken: 4.120 minus 3.140 is equal to 0.980 seconds. Average time for machine 0 equals 0.808 plus 0.980 / 2 is equal to 0.894. The final result shows the average time per machine rounded to 3 decimal places. Similarly, we repeat this for other machines. Let's now carefully break down how we solve this problem using SQL. Whenever you're solving problems that involve comparing 2 related rows, like finding the time difference between a start and end event, one of the most powerful tools in SQL is aggregation. This includes functions like min and max. In our case, each machine can run multiple processes, and each process has exactly 2 activities, one start and one end. Our task is to get the duration between the start and the end timestamps for every process, and then we need to compute the average duration for all the processes of each machine. Now, instead of trying to join the table to itself or use complex window functions, we can simplify it by grouping the data by machine and process IDs. Here's the key insight. Within each group, there's exactly one start and one end timestamp. So, by taking the minimum timestamp where the activity is start, we get the start time for that process. And by taking the maximum timestamp where the activity is end, we get the end time for that process. Subtracting these two gives us the processing time for that process. This step essentially converts the data into a table of machine IDs, process IDs, and the time taken for each process. Now, we have a table where every row shows the time taken for a specific process on a specific machine. The next step is straightforward. We now need to compute the average processing time per machine. We simply group the data again, this time only by machine ID, and take the average of the processing times we just calculated. Finally, we round the result to 3 decimal places to match the problem's requirement. Why is this approach powerful? Because it scales easily even if the number of processes or machines grows. We're only doing 2 groupings, one to get the time taken for each process, and another to get the average per machine. In the real world, this approach is especially valuable for analyzing logs or event data where every process has a clear start and end. It's often used in performance monitoring, transaction processing, and machine activity tracking. The key takeaway here is, when you have start and end pairs, grouping combined with conditional aggregation using min and max makes the solution extremely elegant and robust. The SQL solution here is highly optimal because it uses simple aggregations with min and max, avoiding complex joins or window functions. It runs in linear time, making just 2 passes over the data with efficient group by operations. The query scales well even for large datasets, especially with proper indexing on machine_ID and process_ID. This approach is clean, fast, and production-ready for similar time-based problems. Now let's solve this problem using Pandas, the most popular data analysis library in Python. The great thing about Pandas is that it makes reshaping and manipulating tabular data feel almost effortless. Here's how we can think about the problem from a Pandas perspective. We start with a data frame that looks like our SQL table, containing machine IDs, process IDs, activity types, and timestamps. Now, one of the most powerful operations in Pandas is called pivoting. Think of pivoting as reorganizing your table to make analysis easier. In our case, we want the start and end timestamps for every process to sit side by side in the same row. That way, we can easily subtract them to get the processing time. So, we pivot the table using the machine ID and process ID as the row index, because these two together uniquely identify each process on a machine, and we use the activity type as the columns. This creates two columns, one for start times and one for end times, with each row representing a unique process. Once we have this pivoted table, calculating the processing time is simply a matter of subtracting the start time from the end time. That's it, no complicated loops, no merging, no extra fuss. Next, we need the average processing time per machine. To do this, we group the data by machine ID and take the mean of the processing times we just calculated. Finally, we round the results to 3 decimal places to meet the problem's requirements. This approach in Pandas is extremely clean and efficient. What makes this method especially beautiful is that it's highly intuitive. The code directly reflects the logic of the problem. Pivot the table to align the start and end times. Subtract to get durations. Average the durations per machine. Why does this approach matter beyond just solving this problem? Because in real-world data analysis, we frequently deal with paired events like start and end times, whether it's analyzing user sessions, transaction durations, or machine operations. Knowing how to pivot and aggregate data like this is an essential skill for anyone working with time series logs, process monitoring, or manufacturing data. And here's the hidden gem. Pandas lets you write code that not only solves the problem, but also stays readable and maintainable for future analysis. This Pandas method is efficient, elegant, and scales well for larger datasets. Let's now take a step back and reflect on the bigger picture. Because this problem offers some amazing insights that every developer and data analyst can benefit from. Insight number 1. The most important skill in both SQL and Pandas isn't just knowing syntax. It's knowing how to reshape data effectively. Whether you use group by with min and max in SQL, or pivot in Pandas, it's all about transforming your data into a format where the calculation becomes simple. Insight number 2. In both approaches, we didn't need complex loops or advanced tricks. Why? Because we aligned the start and end rows in a structured way, and that's often the fastest route to solving time-based problems. Insight number 3. Always think in terms of steps. Identify what your grouping units are. Here it's machine ID and process ID. Find what metrics you need. Here it's the start and end timestamps. Transform the table to align them together. Calculate what you need. Here the duration and average. This mindset applies universally, whether you're solving a LeetCode problem, analyzing logs, or building a production data pipeline. Insight number 4. Start developing a mental checklist for these types of problems. Do I have clearly paired events? Can I aggregate or pivot to simplify the data? Can I reduce the problem to a simple math operation once the data is shaped correctly? Insight number 5. Finally, both Pandas and SQL are just tools. The real power lies in how you break down problems. The most successful developers and data analysts are the ones who can look at a problem and mentally reshape the data before they even touch a keyboard. This problem teaches you exactly that skill. And that brings us to the end of this deep dive. Today we didn't just solve a LeetCode problem. We walked through the entire thinking process behind both SQL and Pandas solutions, learned how to approach time-based problems, and explored valuable insights that you can apply in the real world. If you found this video helpful and want more clear, beginner-friendly explanations like this, be sure to like this video to support the channel, subscribe if you haven't already, and most importantly, drop a comment below telling me, what was your biggest takeaway from this video? Or, which LeetCode SQL or Pandas problem should we solve next? Your feedback helps me improve and serve you better. Thank you so much for watching. Keep learning, keep practicing, and remember, the more you solve, the better you evolve. This is Bug No Jutsu signing off. See you in the next video.